Now that we understand how regression works and how to make inferences based on our data, I want to discuss the assumptions that underlie a linear regression. I'm going to begin the discussion by talking about the difference between sample residuals and population errors. The reason for that is that these assumptions are ultimately assumptions about the distribution of the population errors. And so population errors should not be confused with the sample residuals. They are not the same thing, but they are closely related. If you remember, when we are doing a regression, we are always doing regression with a sample of data from an overall population. And we are trying to use that sample of data to say something about the relationship in the population. Sometimes we have a simple random sample from the available dataset. We could collect more data, but we are only using a subsample of all the data we could have. This might be a sample from a survey or a poll where collecting more data would have been too expensive. It might also be a sample drawn from an existing large sample of data where it was too computationally expensive to process all of the data. This happens all the time at large firms like Google and Amazon. They actually never run their estimates on the full dataset. They always draw a subsample from it and run their models against that sample. Other times, we are going to use all the data that we currently have available and think of it as a sample of all the data that will or could ever be available. When we are looking at the relationship between ratings and the review length for restaurants in the capital area, we could actually use all the data for all the restaurants in the capital area. We can think of this case as a sample of all data. We cannot make the sample larger, even if we wanted to. In both cases, we likely won't find the true population parameters. Even if we use all the data, there is some noise in the data, the errors. And this noise is going to affect our estimates. Let's talk a little bit about this noise. There is a true relation in the population, so there is a true line of best fit. The error is the distance between each value and the true line of best fit that we cannot observe. We cannot know what the real alpha and beta are in the population, even if we have all the data available. This means that we'll never actually observe the population errors. By contrast, a residual is the distance between each observed value and the estimated line of best fit, with beta hat. Since our estimates alpha hat and beta hat are always a bit off with respect to the population values, we can only get the residual instead of the error for each observation. The advantage of that is that we do observe these residuals. They are numbers we can calculate. By looking at the residuals, we can make inferences about the distribution of the population errors, which is what we are interested in. In this video, I'm making a very specific distinction between population errors and sample residuals. However, I do want you to be aware that in common parlance, most people make no distinction between residuals and errors. They use these terms interchangeably, and that's why we usually represent the residuals with an E. But when we're talking about regression assumptions, it is very important that we make this distinction clear. Here are some simulated data. Since they are simulated, we know what the true line of best fit is because we entered it ourselves in the computer. It is represented in purple here. Let's visualize the sample residuals versus the population errors. So let's say we draw a subsample represented in blue here, and we compute the line of best fit with a regression. This line is represented in green. While the true line in purple and the estimated line in green look similar, they are not exactly the same. If we zoom in the range between x equal 2.4 and x equal 2.8, represented on the right graph, we see that these lines are actually a bit apart. For the blue point, the residual is the distance between the green line and the point. We can measure it. The error, however, is the distance between the purple line and the point. Since with real data we don't know what the purple line is, we cannot know this error value. So what does this mean when we talk about linear regression assumptions? Well, the regression assumptions are going to be about the distribution of the population errors that we cannot know. We have represented this distribution in red on the right for the simulated data. But we can think about the sample residuals as being indicative of those errors. So we can look at the distribution of our sample's residual instead, in blue on the right. We can use the distribution of the residuals as an approximation of the distribution of the population errors, and guess if the regression assumptions are likely violated or not. We are now ready to talk about the regression assumptions.